So I just want to do a quick little summary of this chapter because I know we hit you with a lot. So we were dealing with sound waves and in terms of music. And we did a little bit about sound waves early on, and I showed you some videos. But we concentrated on a couple different topics. The first is to create notes in music. We had to create standing waves on the instrument. Those standing waves only happen at specific frequencies, and those are the notes we end up playing. So for instance, on a string instrument like a guitar or a violin or a harp, where there has a string and it's fixed at both ends, that means we have nodes at those ends. Only certain types of standing waves, patterns of standing waves, can exist on that string, and those are the notes we play. And there's the formula. F is NV over 2L, where the speed, V, is the speed of sound in that material, in that string. And that depends on tension and the mass density of the string. And then we looked at wind instruments. We looked at a wind instrument that had both ends open. In other words, there was antinodes at each end. That, for instance, is like a flute. And you'll notice, to get a standing wave in a column of air for that instrument, we're given the formula NV over 2L, where N is 1, 2, and 3. But this time V is the speed of sound in air, since instead of the string vibrating, it's air molecules vibrating. And we're going to use the standard 340 meters per second. So you notice both those formulas are pretty much exactly the same for a string instrument fixed at both ends and a wind instrument with both ends open. And then we finished it off by looking at wind instruments with one end closed. With a wind instrument with one end closed, an example is like a reed instrument, like a clarinet or an oboe or even a saxophone. And it had a slightly different formula. Because it had to have an antinode at an open end and a node at a closed end, only certain patterns of standing waves could fit in there. And it turns out the mathematics are NV over 4L, but N can only be an odd number. But we still use the speed of sound in air as 340 meters per second. Now, any questions we do at Physics 11-14 level are just going to involve these formulas. Nothing fancy, nothing too difficult. It's pretty much just using these formulas to plug in numbers. But out of interest, and to help you understand this, I'd like to point out a couple of things. First off, notice that the frequency of notes that they play depend on, for instance, in the string instrument, the length of the string. So you'll notice, for instance, that if you go and look at a cello player or a bass player, they have much, much longer strings. That means they can get lower and lower frequencies. Because look at for the string instrument, L is in the denominator. So if L gets bigger, that means F decreases. So you have one of those standing basses, and you can get some really low notes because the length of the strings are so long. Similarly, for wind instruments, L is the length of the tube. Now, one of the neat things about physics is we were showing examples with straight tubes. These still work if you bend the tubes. So wind instruments like trumpets and saxophones have the pipes bent, but that's okay. That just makes sure you can have a longer pipe in a shorter space by bending it around. You'll also notice for people playing the flute, they move their fingers up and down, blocking holes on the top of the flute. What they are actually doing with that is when they plug a hole, they're in essence changing the length of the tube where it's open to the air. Similarly, for a trumpet or a saxophone, when they hit the various keys, they are actually changing the length of the tube, which means by changing L, they can play different frequencies because the speed of sound in air is a constant. If you can change L, you can actually change the notes you're playing. A piano does this too, by instance, for string instruments. If you ever open up the back of a piano to look on how it plays, all the strings are at different lengths. That allows different keys, when they hit the string, to vibrate it to play different frequencies. So next time you're looking at musical instruments, take a look at that. It's kind of interesting to see all of that. All right, that's the summary. Thank you for watching. Please come see me with any questions you have. Other than that, have a great day.